4-2, Part 1. Using scientific notation to describe very large quantities. When you are working with large numbers in standard form, it is helpful to express them in scientific notation. Looking at this number, 384,000. We are to write this in scientific notation. Now remember, your decimal has to be behind the first non-zero digit so that the number is greater than or equal to 1 and less than 10. So I would write it 3.84 times 10 to some power. Now, think about it. If the decimal is behind the 3 in the scientific notation form, but the decimal is behind the 0 in just standard form, every number has a decimal. If you don't see one, it's behind the last digit to the right. But in scientific notation form, it's behind the 3. How many places will we have to move our decimal to the right so that it ends up being at the very back? Well, let's move it. If it's here in scientific notation, let's move it. 1, 2, 3, 4, 5. We're moving it to the right. Going to the right says positive exponent. So my exponent is positive 5. So scientific notation of this number would be 3.84 times 10 to the 5th. But your decimal has to be behind the first non-zero digit. Let's look at another one. You can also rewrite numbers expressed in scientific notation in standard form. So in the previous example, we went from standard form to scientific notation. In this problem, we're going from scientific notation to standard form. So, we have the numbers 7, 3, 2, and my decimal is here. I'm in scientific. This 10 to the 6 tells me to move my decimal to the right 6 places. 1, 2, 3, 4, 5, and 6. Now my decimal's back here. Fill in all the open spaces with zeros. So I end up having 7,320,000 for my standard form.